We see climate-smart agriculture as fully consistent and aligned with food security goals, and by and large that our food security investments are also aiming that same direction in terms of aligned with climate-smart agriculture. But I think the point here is that we can always do better, and I think that's what this week is about. The irony about having this kind of discussion here in a USAID funded forum is that Congress doesn't give us our money for the mid-century. Congress gives us our money to drive reductions in poverty and hunger in the coming few years. So that presents us, I think, with sort of an existential challenge of how to balance a long-term vision around global food security and environmental security in addition with the near-term needs of the hundreds of millions of food insecure people we're seeking to help. And I think part of what climate-smart agriculture is about is to help us reconcile this, helping us take climate change into account in all our thinking around food security investments, be it for adaptation, trying to anticipate what's coming, anticipating those changes that are going to happen along the way. So in a sense, we're asked a little bit to see the future while not losing sight of the present. The point here is that global climate change is underway. The drivers are already in place. We know that temperatures are rising. We don't know exactly what's happening with precipitation. Some places it may be going up, some places it may be going down. Wherever it is, it's likely to become more variable and with less certainty around things like seasonality and reliability. We also know that there are major biotic changes being driven by climate change in terms of the expansion of pests and diseases into areas where they perhaps were not before. We also know that we're going to have, in just the next 10 or 15 years, another billion people to feed, and a rapidly urbanizing planet, which has both opportunities and challenges for the agricultural sector, and that demand is growing faster than population because of income growth. And again, the opportunity side of that demand growth, from my perspective, is that it will help us drive diversification, which is a good thing from a climate resilience standpoint. It's probably going to mean more opportunities for higher value products and more investment, which is good profit opportunities for smallholders. And also, a lot of what it's going to drive is going to be diversification into higher nutrition density types of commodities, horticulture, animal source foods, etc. And finally, another big opportunity from my perspective is that many of those kinds of value chains and economic opportunities have very significant gender opportunities associated with them. So the next slide is something else that we know, that we're going to have disproportionately negative impacts on developing countries' smallholder agriculture. The people we're trying to serve are the people least prepared to adapt. They lack capital, they lack access to innovations. In many cases, the innovations just lack. I mean, Greg Sachs at Columbia University has been very clear about the big difference between the tropics and subtropics versus the temperate zones in terms of the degree to which there has been investment around global public goods in agriculture, health, and other key sectors. We know that higher commodity prices are likely here to stay, and that has a mixed blessing, perhaps more profit opportunity, but many of the smallholders we're trying to serve are net consumers, so they could also suffer from that. Demand is expected to stay strong, in other words, low elasticities with respect to those higher prices, perhaps because of that growing income and growing population. Before we go further, though, let's remind ourselves about the three pillars of climate-smart agriculture. Productivity and incomes up, the first one, right at the heart of our food security theory of change. Adaptation and resilience up, again, right, very clear around our risk reduction focus. And then the greenhouse gas emission reduced. But last night our colleague from the AU, it was interesting, he projected that as reducing the emissions intensity associated with agriculture, which I think is an especially appropriate point of view from the African context, although even the African context is varied, and we'll say a bit more about that. But the idea here is to, whatever we do, it's not business as usual. We're trying to bend that curve or, in some cases, absolutely reduce reductions. And then I also wanted to just remind you of another thing we like to say, and that is that climate smart agriculture is smart agriculture informed by climate science. So if that's the case, what is smart agriculture? Probably the biggest challenge we face in agriculture, absent climate change, is water. Once you've got adequate water, a lot is possible, and I'm delighted that we have people from the water community here to talk about that with us this week. Water lowers your risk and it raises your productivity, incentivizes investment. But look at our main agricultural regions on this map. Many of them face water scarcity. Blue water, I think, is surface water through important portions of the year. And at the same time, we see that poverty remains concentrated in the semi-arid tropics, and these are, in fact, the major agricultural production areas. It's not those equatorial zones with all the green. Those are forests by and large and less populated. It's, in fact, the drier areas where the great concentration of agriculture and population is. And of course, 70% of global freshwater use is for agriculture. And I think the authors of this paper, which is quite recent, made the point that balancing human needs with water, primarily agriculture, and ecosystem needs for water is going to be one of the fundamental challenges we're going to face going forward in this century. And I think, so water management is key to smart agriculture, and now that includes irrigation, but it's certainly not limited to irrigation. And we're going to be thinking this week, too, about water use efficiency, which an area where there's terrific opportunities for increases in smallholder systems. And finally, climate change is going to exacerbate the situations we see here. We know that there'll be more intense events, more droughts, less reliability, and because of higher temperatures, more evapotranspiration, which will potentially affect both surface water and groundwater availability. While water shortage and drought are very, very important in the context of climate change, there's also the heat impacts, not just on water, but on the biological processes that we depend on, the extreme events, the biotic stresses I mentioned earlier, the more rapidly changing pests and diseases that smallholder farmers will face in their production systems, and even biological nitrogen fixation is going to be negatively affected. It's not favored by higher temperatures, and it's certainly not favored in less fertile soils depleted of organic matter, which unfortunately is frequently what we find in the African context. So, thinking about soil fertility, another big challenge in agriculture and smart agriculture and managing soil fertility. Let's take a look at nitrogen. And I'd like to say that I'm not sure about this, but I would argue that probably what you see on this slide around nitrogen use, which as you can see is uneven and with substantial overuse in many ecosystems, is probably also a surrogate for mechanization and irrigation, because it's a surrogate for capitalized systems. So what do you notice about Africa? It's very pale. And as I say, in other regions, for example, in South Asia, we can see areas of overuse, and we certainly don't want to emulate that in the context of sub-Saharan Africa. But reducing emissions intensity, what our AU colleague talked about last night, in ways that foster food security is probably going to require more and smarter use of fertilizer in sub-Saharan Africa. So it's not the first thing that comes to mind for many people when we think about climate-smart agriculture, but if we're serious about emissions intensity reduction, it has to be quite central. Now, as I said, we don't want to think in isolation, though, because soil fertility is more than fertilizer. fertilizer is much more effective when there's a good amount of soil organic matter. So we have to think about managing soil organic matter as well as inorganic sources of nitrogen and phosphorus and other minerals. This, I think, is going to lead us to have discussions this week about the role of legumes, again, around biological nitrogen fixation. By the way, legumes actually provide 30% of the nitrogen in the human diet, which is really a very impressive amount. And fertilizer remains expensive in Africa, so I think there's going to be things that also behoove us to be thinking about really integrated approaches that take into account legumes, fertilizer trees, as well as mineral fertilizer, with an emphasis on efficiency. And efficiency is going to be one of our best friends in this whole discussion of climate-smart agriculture. How can we use resources more efficiently? I'd like to posit here that sustainable intensification, which has been at the center of our research strategy in Feed the Future, needs to be climate smart. So we need to be able to think of productivity and adaptation going up, but also emissions or emissions intensity going down. And I think we need to be able to think about risk reduction. It's always been at the heart of it, because really this is ultimately about fostering investment. And that's where climate services are going to come in, and I'm glad we're going to be talking about them this week. We are going to see a lot of situations where adaptation and mitigation go together. I like to call it co-adaptation, where we're getting that triple win that we all strive for. As I said, resource use efficiency is critical. And I think what we're going to see is that climate-smart agriculture is wholly consistent, not just with environmental drivers, but also with economic drivers. I think Pat Diskin last night talked about the profitability issue. And often that resource use efficiency is directly linked to that profitability for the people we're trying to serve. So input efficiency and strategic use and management of both inorganic and organic inputs, and ultimately more choices for farmers. Technologies, whether diversity within a crop, new genetics, or new crops that have greater adaptability. And the same can be said for livestock. New variation and variability within livestock, new approaches to combating some of the biotic stresses that affect animal health. And I think, again, this is why we're going to have a lot of focus this week on seed systems, on input systems, and on the knowledge systems that provide smallholder farmers with the tools they need to up their game with respect to climate-smart agriculture. And then finally, just at the risk of repeating, I think so much of what we want in sustainable intensification is information intensification. Information about technologies, about what farmers can expect if they do one thing versus another, about markets, about their prices that they can expect, and about weather, or seasonal forecasts, to the extent that we can drive those forward and make them available. So again, climate services are going to be really essential. So let's take a look at an intensified system. This is less typical here in Africa. This is from South Asia, an area where both CCAFS and the CISA, the Cereal Systems Initiative for South Asia, which is something that the Bill and Melinda Gates Foundation and USAID fund together, has focused on climate resilience and productivity, and yet what we're seeing here is a terrific triple win with respect to greater adaptation through heat-tolerant crops, through the integration of more crops in the cycle, for example, legumes during the hot season, through diversification into fish ponds, and all kinds of farmer innovation within the system, through technologies like deep placement urea that increase the efficiency and use of fertilizer, mean less environmental pollution, but also less greenhouse gas generation into the atmosphere. And finally, a really exciting savings in terms of energy and resources. Less water being pumped, less greenhouse gas emissions from running the pumps, greater efficiency in the use of that water, and of course moving to a no-till or zero-till system, so saving huge amounts of fossil fuels. Another area where we want to keep in mind is leveraging the biological sciences in our work. We're going to talk more about this week, but I just want to give you a couple of examples. On the top, the heat-tolerant maize in Asia, where we're using advanced technologies, and within just 3 years, we have produced hybrids that are outperforming all the local checks, and you can see that picture. And that's about heat tolerance. So heat tolerance is a huge issue in South Asia, and it may be in parts of Africa as well, and it certainly likely will be in the future. But there is biology that we can marshal to help us adapt our crops and our livestock, that we're also working on heat tolerance in poultry, to this emerging threat. Another area is the drought-tolerant maize for Africa, the lower picture, and that's one cob under drought stress, and one on the left that was DTMA, drought-tolerant maize for Africa, under that same stress. And you can see the difference. And we're going to, there's a lot that drives that kind of change, as you can see, some of the factors that are there. But again, just underscoring the potential for the biological sciences to contribute to our work. And again, the reason that seed systems are going to be so important in terms of delivering these choices to farmers. Our work in this area is not limited to adaptation. We're also working on nitrogen use efficiency. To the degree to which that trait can really go forward globally is going to be very significant, because it's going to have huge impacts on the efficiency of fertilizer use and the reduction in the level of fertilizer being used. A big win for the atmosphere, but also for the through the carbon generated through the Haber process to generate all that nitrogen industrially. Finally, we are working to diversify the genetic base of crops. We have some fantastic work in chickpea. When crops were domesticated, this was a huge bottleneck, and so many genes were left in the wild relatives. So we're working now to really take a look, not just at the germplasm we know, but the wild species that contain potentially genes for heat and drought and other kinds of biotic and abiotic stresses that will become increasingly important in a climate-challenged world. The next slide basically shows us two trajectories, one in South Asia and one in sub-Saharan Africa. One is extensification in sub-Saharan Africa, where we've more than doubled the amount of land in production in the last 50 years, versus South Asia, where we've more than doubled the productivity and only used about 20% more land. And that has huge impacts, not just on driving poverty and food security improvements, but on sparing the environment and helping to ensure the availability of environmental services and helping protect key fragile environments. So what happens at the local level has global implications, and I think it's that old saying, you know, act locally and think globally. Well, this is an example where that's absolutely true. And sustainable intensification, I think, can help us change the picture of what's happening in sub-Saharan Africa. And I think if we had more recent data, we'd be starting to see that already based on the levels of investments and some more recent data on productivity growth. I want to not leave this topic without saying that part of sustainable intensification is that smallholders in sub-Saharan Africa are still going to need access to capital. We have to figure out ways to capitalize African agriculture, hopefully through a smallholder lens that helps drive our poverty reduction, that reduces risk and drudgery, that helps foster investment because of reduced risk. Lots of opportunities. It's already happening around service provision that spreads the capital risk, working with farmer organizations that helps aggregate supply and demand, again, helping make markets more attractive, both for the market systems but also for producers. And I think ultimately raising some of the points that Pat Diskin raised last night about agricultural transformation going forward, and what is that going to look like. So, but solving the undercapitalization of African smallholder agriculture is going to be part of it, and I think we have to keep in mind we want this to be part of an overall emissions intensity reduction strategy. And I know the literature, hopefully we're going to hear some about the literature that exists around intensification. By and large, we tend to see that emissions intensity go down as sustainable intensification goes up. But that's something we need to keep an eye on and continue to work for with a low emissions development focus in view. I think here again, the public sector has an important role with respect to policy to help incentivize this kind of investment, and the private sector to respond to those opportunities. And of course, a lot of you are working in ways through your programs to do just that. And finally, let's not forget, I've been talking a lot about production, but climate-smart agriculture has to be about the whole agri-food system. There's huge opportunities for both adaptation and mitigation gains across the whole market channel, and I'm very happy this week that we're going to be talking about that, talking about incentives to bring the private sector in as an integral partner into our climate-smart agriculture efforts. And again, I think what this is going to hinge on ultimately is that the opportunities that await us are really fully consistent with economic profitability drivers, because that is around resource use efficiency, that's around more efficient markets and trade, that's around innovations that require less energy for things like processing. It's around streamlining trades and markets so that less time is spent at transit times at borders and so forth. And so this is something else we really want to keep track of, particularly as we think about our value chain investments in Feed the Future.